had bankrupted the company, and Derby was in crisis.
There's hardly a family in the town that hasn't got someone working at Rolls, not just as manual workers and skilled craftsmen, but as research workers and designers. When the men came out lunchtime, they were obviously shaken.
Shocked. Just shocked.
Looks very bleak, that's all I can say. I mean, looks very bleak, doesn't it?
Did you ever believe this could happen here?
Never. I've been here 27 years and I've never thought anything like this could happen.
I think the government ought to really back us up a little bit. Quite a lot, because it's a household name, isn't it, Royce's?
The government came to the rescue, saving thousands of jobs and giving Rolls-Royce and the people of Derby one last chance.
The progress that was made during the following 12 months, 14 months post the bankruptcy was quite remarkable. And we actually managed to get the engine into service at the end of April 1972.
When the TriStar finally flew, the hard work and revolutionary technology paid off. The engine became the jewel in Rolls-Royce's crown. And it still is today, as the basic design of the entire family of Trent jumbo jet engines. Launching Rolls-Royce onto the international stage, the engine helped them grow from a small player to a global competitor. Today, Trent engines are fitted to half the world's big passenger jets, with new orders worth over £40 billion. At the heart of the Derby factory is the main assembly line for all Trent engines. The line has to run like clockwork to take every build from first components to completed engine bang on schedule.
From the moment we launched the kit to make the first internal module right through to the engine being dispatched, it's 20 days.
The countdown starts with assembly of the biggest and most complex modules. Hundreds of precision-tooled blades, hand-fitted and finished to perfection. 4 days in, and work begins on the engine's Kevlar-wrapped aluminium fan case. Over 4,000 engine control and transmission parts, fitted and wired, every one by hand. At the same time, an army of expert fitters begin the 9-day task of fitting together the engine's 8 separate modules. The first 5 sections are stacked one on top of the other. With gravity helping the process, it's a lot easier to achieve a perfect fit. Every bolt is adjusted to a precise torque, and there are moments that require absolute concentration.
Going down.
We're having to pass through the whole of the O4 module before we arrive at the coupling in the O3 module, and we take all the care we can not to touch the sides. If it ticks the paint off the shaft, then we have to recoat the paint for protection. It's the trickier of them all to fit, mainly because of the coupling that you can't see and the adjustment that's needed.
Going down.
There's the 2 shear keys that will ride up and locate in the slot. You should hear as it clicks. They'd have clicked in now.
1 week into the build, the fan is assembled from its kit of blades. And with each one worth as much as a family car, it takes an expert touch.
We prefer to wear gloves. It keeps fingerprints off the blades and this grip as well. So it does stop them slipping out of your fingers.
You don't want to drop it, do you?
Certainly not. Certainly not.
Before the fan can be fitted, the towering engine stack is craned onto its side. Two tons of precious metal swinging just feet from the ground. Finally, in the position it'll spend the rest of its life, the engine's ready for the last 2 and biggest modules. The fan is a perfect fit. Its tips clear the lining of the case by a fraction of a millimetre, yet in flight will spin faster than the speed of sound. After 2 weeks of assembly, every completed engine is fitted with vast aerodynamic ducts and inched across to the factory's purpose-built flight test centre. Here, it'll be fired up and put through its paces in a simulation of the harshest flight conditions.
3, 2, 1.
While engineers monitor vibration, rotation speeds and temperatures to ensure everything performs perfectly.
Vibration is looking good. Max conditions now. Hands down to
3, 2, 1, go.
Signing off newly built engines isn't all they do at the test centre. Dave Benbow is in charge of testing prototypes for new engine designs before they ever take to the sky. And that means carrying out tests that are much more challenging.
We run thousands of hours of testing. Our primary requirement is to show that the engine is safe to fly, that it's airworthy. We conduct a number of tests to do that, but really we're trying to meet the regulations of the safety agencies. This engine is a flight test engine, and in that extent it has a lot of instrumentation that production engines wouldn't have, that you can see here is led up off the engine and into the pylon so that we can record the data on the test bed when it's installed.
Testing is so exhaustive, it can take 2 years for each new design.
The cold start test is a very important test. We need to be able to start the engine under cold conditions, cold as minus 40 degrees.
Removed from its giant freezer, everything must still work perfectly when the engine is started.
We have to make sure that the gearbox will turn when we start the engine. Other tests, so water ingestion.
Water is poured in at 30,000 gallons an hour, but there must be no loss of thrust.
We have to demonstrate that the engine can cope with rain and hail ingestion, and that the compressors can cope with the amount of water going through the engine that it might get in flight, and that the compressors continue to run and that the combustion system remains stable. But one of the key safety requirements we have to ensure we meet is that in the unlikely event of the release of a fan blade, that it's contained by the fan case. Well, it's an absolutely key test in that we need to make sure that there's no chance of the fan blade escaping. On the test, there's an explosive detonation which releases the blade from the disc at max takeoff speed and fires it into the fan case. When this event happens, the energy that's generated by the blade coming off is about the equivalent of a 1-ton car being dropped off a 200-foot cliff. And the casing here then has to retain that and ensure that nothing is released outside of the fan case structure. So it's a hugely expensive test, but our commitment to safety and demonstrating requires us to take that asset and to complete that test, irrespective of what we're left with in the end. The engine is destroyed. Although it's contained the blade and run down safely, the components that are in that engine will not be used again. Effectively, that engine is then written off.
Only by sacrificing an entire engine like this can they be sure the fan case really does its job. It's 6 in the morning and the start of another shift on the assembly line for fitter Andy Taylor.
I just work round the corner from here, so I work on where they build the stacks. Work 3 shifts, work mornings, afternoons and nights. I'm on mornings this week. Morning. That's the inspection department, very friendly people there. This is my engine for today.
Andy's task today is to fit the first of a network of sensors to the engine.
These are connected to the thermocouples, and these tell the brain of the engine that if there's an overheat problem, it'll tell it to like alter something inside the engine to cool it down, or vice versa if it's running too cold.
When it's running, these sensors will measure temperatures, pressures, speeds and vibration at critical points in the engine. The sensors constantly feed that information to the engine's own electronic management system, its brain, that ensures performance is optimized at all times. But it doesn't stop there. Data collected from every Trent engine in the air can even be transmitted via satellite back to Derby. It's received here at the factory's 24-hour monitoring station, manned by senior engineers to keep an eye on Rolls-Royce engines all over the world.
Alan, we've got an issue on engine 41992. We can just see that the exhaust temperature's just going up on that engine.
This is 21st century jet engine production, part of a high-tech support package that gives them a commercial edge over competitors.
Increasingly now, as the airline buys a Rolls-Royce engine, we secure a service package with them, sometimes for as long as 20 years, where we will provide all the maintenance, all the spare parts for their engine. We will make sure they have engines available whenever they need them to support their aircraft, and they simply pay for the number of hours they fly.